Let's have a look at Nvidia's Blackwell AI chip. And we are going to look not only at the Blackwell GB200 Grace Blackwell superchip, but we are also looking at the AI factory, or the packaged AI server, so to say, GB200 NvL72 that is sold for $3 million by Nvidia. And we are also going to look at some demand patterns that we can already see today. To estimate the revenue next year, we can expect potentially this year, because people would have to order it already this year. We can expect based on the Blackwell super chip. So this is really exciting new technology. The name is GB200, GB short for Grace Blackwell 200 super chip, and it is a processor for trillion parameter scale generative AI. This is how it looks. We are going to look at a short video clip by Jensen in a minute. And the performance is it's like 40 petaflops, 864 gigabyte of fast memory, 16 terabytes per second, and 3.6 terabyte per second of NVLink bandwidth. And so what does it mean exactly? I've made a quick comparison. So I checked out the stats for my own Nvidia GeForce GPU in my computer. I have a commodity hardware like by Acer, not affiliated with them in any way. I'm like, this is just very average hardware, years old, but it's like, it might be like the GPU you have in your PC, right? If you have not purchased the newest PC like this year or a year ago, you might have similar GeForce comparison. And now look at the performance difference, the most important performance difference. So if you check out like your Nvidia MX 150 that you might have in your own PC, it has like 1.127 teraflops. And actually maybe I have created this metric table here where you have flop. What does it mean? Flop is floating point operations per second. And teraflop is 1 trillion floating point operations per second, right? And then we have petaflops, which is a quadrillion, so 1,000. So 1 petaflop is 1,000 teraflops. So we have flops times 1,000 is kiloflops, times 1,000 is megaflops, I think, times 1,000 is teraflops. Actually, I missed something. So because 1 teraflop is 1 trillion, 1 trillion is like 1,000 billion, right? Floating point operations per second. A petaflop is quadrillion. Okay, so this is like huge numbers of operations. And you can see the GB200, the super chip, one chip has like 40 petaflops of AI floating point operations per second. And if you would compare like integer operations per second, it would be even higher, right? We have checked out the 1-bit LLM paper in a recent video on the Finxter channel. By the way, subscribe to the Finxter channel if you want to stay updated with the newest AI disruptive innovation content. My main purpose with the Finxter channel is to help you be on the right side of change, and I really appreciate all the new subscribers we have recently seen. I appreciate the rapid growth of the channel to like 16k subs or so. Really grateful to have you here. So please give me a like for this video if you like this stuff, and subscribe to the channel. Okay, so back to the performance difference. You see, like we have the difference between my own GPU and my computer and one GB200 chip would be 35,000 x. So this is like this is like 3,500,000% different. It is like from another planet, right? It is like the operations, like this is one chip. It is not like the whole server. This is not like this server rack, right? That consists of 72 GB200. This is just a single chip. A single chip is like 35,000x difference in terms of AI compute performance. So you see, you would have to connect 35,494 commodity machines in a cluster in order to get to the same training performance. And probably it would be even worse because you would not have the same bandwidth. For sure it would be worse because you would not have the same bandwidth between those GPUs if you connect them in a, say, peer-to-peer cluster over the internet. And there are some like shitcoin crypto projects that actually promote this kind of, we are a distributed AI inference network or something, some bullshit like that. It will never work because it's just from another planet, right? Like the Blackwell superchip, so the centralized AI chips. These are just the performance difference is so huge, and there would be no normal person like you and me purchasing like a GB200 for his own use at home, right? It is just too expensive. It is too expensive to run. It is too inefficient because you don't have the hardware. You need too much of expertise to run this efficiently. And that's why these kind of peer-to-peer AI crypto networks will never work, as a side note. Good. Okay, so you see the huge performance difference. Some stats. The GB200 NvL is now based on the GB200 superchip that we have just seen, but connected with this Nvidia NvLink connections, right? And we connect 72 of Blackwell GPUs to like one rack. And let's have a look at the video that is actually presented by Nvidia. So this is one crazy Blackwell superchip. So you see they connect 72 of those Blackwell super chips. Not even in a rack. A rack then would be probably even more. NVLink switch, communication technology. They package them together. And then you put 3 of them into one rack actually. So it would be even more powerful, one such rack. Oh no, okay, so this is actually it. Okay. So, and this actually gives us a glimpse into the Nvidia's future, right? They won't sell single chips anymore to people like you and me. They sell like whole data centers, and the revenue they can extract out of those kind of configurations is multiple orders of magnitude higher. Liquid cooling system. And I mean, this is the future. AGI will run on those type of data centers very soon, maybe 2027 or so, as many experts predict. So here we have 32,000 GPUs in a whole data center. And people are excited about this, as they should be, because the future will be really different.
Blackwell is not a chip. Blackwell is the name of a platform. People think we make GPUs, and we do, but GPUs don't look the way they used to. Here's the if you will, the heart of the Blackwell system, and this inside the company is not called Blackwell; it's just a number.
Okay, so you can check it out. It's definitely a good. I will give a link in the description below to this video. But let's go back to the Blackwell presentation. And I think so. It is like the impressive performance that is offered by such a GB200 NvL72 configuration cannot be met by any other company on the planet. There's like one of the biggest competitors, and I put it in air quotes, is AMD. And AMD actually has only 1/10 of the revenue for AI training chips I checked before compared to Nvidia. So Nvidia is in a rapidly growing industry, AI training, that grows like by 100% or so every year, and they are the leaders. So they are the leaders in a high growth industry, which gives them the opportunity to be either the low cost provider or the high margin player, right? So, and they are kind of both in a way, right? Because of course the AMD chip might be cheaper, but it's also less performant overall, which means that it is they have if you want to have the latest hardware for AI training, the latest and best hardware, you need to purchase the Nvidia chips, even if you purchase them at a premium. And it's often more cost efficient also to just buy the whole rack or the whole data center from them, right? Because of the know-how they provide. Like AMD might sell you the MI300X or so, but if you don't have the know-how, right, to put them together in an optimal way, then you might lose a lot of performance in communication and so the bottleneck might be something else, right? And you cannot really risk that if you, for instance, put too much or too little network connectivity between those AI chips, then the bottleneck could be network, right? And you cannot really risk this. You need, for instance, the NVLink networked connection, and Nvidia has done a nicely balanced product between compute performance and communication performance. And now they say like a packaged AI server GB200 for say 3 million. The technical specifications here are the compute performance. Here we have for floating point with 4 bits tensor core 1440 petaflops, for floating point 8 and 6 tensor core a bit less, right? Because we have seen in the latest video on 1-bit LLMs on the Finxter channel, that it depends like how many bits you need to encode the weights of your matrices that represent the AI models you want to train. And if you use more bits, then each weight has a higher precision, floating point precision, but you pay for this higher precision and better performance of the model. Ultimately, you pay for it with higher bandwidth use and more compute overhead, and it's often better. So we have seen the trend of reducing the number of bits needed to encode each weight of a matrix, and that's why the GB200 also provides lower bit like training bit architectures, right? So for instance, FP4, which was not included in the previous H100 or H200, if I remember correctly, GPUs. Okay, and so here we see, like, if you use integer only, so not floating point, but integers, then you of course don't call it floating point operations per second, so flops, but you would call it pops, right? Pops is for here integer operations per second, and more and more we move also to pops, right? So we use integer representations for the weight matrices we train via those AI training GPUs. Okay, so we have an insane amount of number of operations. Again, let's look at the difference. Here, the GB200 offers a 40 petaflops performance. So it can compute 40, what is petaflops? Quadrillion, 40 quadrillion floating point operations per second. And this is already like a 35,000x compared to my own GPU in my computer. So this is one chip, 40 petaflops. But now if you put them together in the NvL72, if you put those Blackwell chips together in this packaged AI server, now you can actually not get a 40 petaflop, but 1440 petaflops computing performance, which is like, this is huge. I cannot even find words to describe how massive this computational performance is. Good. And some initial evaluations provided by Nvidia. Of course, you need to be always careful. They always try to present themselves from the best side. We will look at this in a moment. Rumors claim that GPT-4 has 1.76 trillion parameters, and they evaluated this on a 1.8 trillion GPT LLM using a mixture of experts approach. This again, we have looked at this in the previous Finxter video on 1-bit LLMs, mixture of expert models, and also in the previous video on parallelizing AI training. 4 different ways of parallelizing AI training. One way is to use a mixture of expert models, where each CPU is responsible for, say, a smaller portion of the model, and then you combine the outputs or smaller portion of the expertise, so to say. So it's like a smaller model. So you have a mixture of smaller models. Each smaller model is an expert in something, and then you combine the output of those different experts using some kind of algorithmic magic. And of course, these kind of approaches are easier to parallelize. So this like already plays into their hands to use this mixture of expert training scenario. But of course, it's still very impressive, right? Because the H100 is what catapulted Nvidia to the point they are, almost being one of the or maybe being the most valuable company on earth, and not quite yet, but almost, right? Like a $3 trillion company, only based on the H100. But now they have like this GB200, which has like a 30x different in performance. Or maybe if you don't trust the numbers too much, you could still say it's like a 10x or an order of magnitude improvement of performance. So again, these are Nvidia's numbers, and you need to be careful because Nvidia is often a bit too optimistic. They are tailored to Nvidia's own strength. They like use the scenarios that would give them those kind of great numbers, but still they are trustworthy in a way. And as we see in the moment, AI leaders actually agree that Blackwell is the best compute infrastructure. That's why Nvidia is the 600-pound gorilla. They are just also very good at sales and marketing, which is one of Nvidia's strengths. So other evaluations reduce the gap against competitors a bit. So for instance, AMD MI300X is the best competitor kind of for AI training, and it has shown to outperforming Nvidia's previous AI training chip, like the H100. You could also doubt AMD's numbers, but okay, so let's assume it outperforms H100 by a bit. The Blackwell chip would still smoke the AMD chip now. And so Nvidia is always one step ahead. Why is that? Because they have the culture. They have invested more than anybody else for 2 decades in research and development. They have the expertise. They have much more scale in terms of sales volume, so they can spend more relatively to the sales they have. They could spend more to acquire the talents. They have the more valuable options to pay their world-class employees and so on. So they have many of those modes, of those advantages, being the leader in a high-growth industry. So Nvidia, like really, let's not mid-curve it. Blackwell is the best AI training infrastructure that money can buy. That's why money buys all of this, and that's why you see like the leaders, Mark Zuckerberg, CEO of Meta. AI already powers everything from our large language models to content recommendation, ads, safety systems, and it's only going to get more important in the future. So you see revenue will grow. We're looking forward to using Nvidia's Blackwell to help train our open source Llama models. So Meta will for sure order Blackwells. Microsoft. Satya Nadella says about the Blackwell: we are committed to offering our customers the most advanced infrastructure to power their AI workloads. By bringing the GB200 Grace Blackwell processor to our data centers globally, so they integrate it into their cloud, so people can use the GB200 and Nvidia's chips in Microsoft's data centers, like the Azures of our world, Azure, AWS, and Google's data center, Google Cloud, are all integrating the GB200 into their data center. So Nvidia will make a lot of revenue just from selling it to those 3 huge, massive cloud customers. Then Sam Altman, CEO of OpenAI, Blackwell offers a massive performance leap and will accelerate our ability to deliver leading-edge models. We're excited to continue working with Nvidia. Larry Ellison, Oracle's close collaboration with Nvidia will enable breakthroughs in AI and so on. Elon Musk, CEO of Tesla and xAI, there's currently nothing better than Nvidia hardware for AI. You see, everybody is using Nvidia hardware. Everybody is using the Blackwell. So they will continue to sell the Blackwell. And now some revenue projections, if you're interested. Elon Musk actually on X announced that not for Tesla, which is like orders of magnitude bigger than xAI, not for Tesla, but for his smaller startup xAI, he announced the purchase of 300K B200 in 2025. This was a rough estimate he gives, but usually like he might do something in this order of magnitude. He has this is not like a product he's building, so it is not like a too optimistic estimate. This is something he will purchase, right? And a purchase announcement, which is usually more reliable than say a product deadline. And so if he really purchases 300,000 B200s, so Blackwells, then let's divide this by 72 to get the number of racks, because here we have calculated that like the NvL72 consisting of 72 those Blackwell chips, it costs 3 million, right? So we want to know how much revenue this actually would generate. It would like, now let's divide this by 32, by 72, and multiply it with 3 million. This is the number, the sales we would generate from this one purchase that is already announced. This is like 12.5 billion if I do the math correctly. And if xAI now, so let's be very, very pessimistic for Nvidia and assume that xAI represents 10% of the global AI training demand this year. Like this would be like the fiscal year 2025 for Nvidia. Let's assume xAI sales represent 10% of that. I would say it's way too bearish for Nvidia, because usually like nation states buy the Blackwell. Meta is much larger than xAI. They purchase a lot of training compute. Tesla scales up their full self-driving fleet. Tesla is orders of magnitude larger, Meta as well. Amazon, we have the cloud providers purchasing the GB200 for just for selling access on their clouds and access to the GB200 to AI training. So those usually also have much larger scale than a small startup, so to say, like an xAI startup. So I would say like the xAI would represent much less of the global AI training demand than 10%, maybe even like 1%. But okay, so let's go with 10% of the global AI training demand. And let's say this was overly bullish. Let's say it's like 10%. Then this year's revenue from selling GB200 will be 125 billion. So for reference, here I added the revenue numbers, the historic revenue numbers. Like in fiscal year 2021, they had 16 billion of revenue. Then in fiscal year 22, they had 26 billion. Stayed at 26 billion for a year, so there was like no movement. This of course can always happen, that we have like a building phase where revenue doesn't grow, but if you are in the right industry, then it will eventually grow. And it did, like it more than doubled the revenue in fiscal year 24. And now already, like given the recent quarters growth of revenue, we have like a 79 billion revenue. But okay, so let's say fiscal year revenue 24 was 60.9 billion. Now we have, like, from this very rough revenue estimate, but a bit, I would say, conservative revenue estimate, we could see like a doubling of the revenue once more, like an additional doubling of Nvidia's revenue this year. So if this would be true, then of course the stock price would still be undervalued. No investment advice. This is just like, it's very rough math. It will be wrong. The only question is how wrong. Okay, so thanks for listening to this video. So give me a like and subscribe to the Finxter YouTube channel. I would love to have you here in the family. I would love to have you on our email newsletter. You can join for free just going to finxter.com, subscribe with your email address. I send out regular email newsletter with like those videos and reminders on new tech trends and AI news that are happening almost daily, sometimes weekly, but regularly, and I keep you on the right side of change, which is the most important thing we can do in our world today, where everything changes so rapidly. If you want to like join the top 5% of people in the space, then you might consider joining the academy.finxter.com. Just you can visit, type in academy.finxter.com and check out our courses. We have a lot of courses designed to keep you on the right side of change, or push you on the right side of change if you're currently on the wrong side of change, by teaching you the content, the information needed, the knowledge, which I should say needed, to become an AI engineer yourself. So become a disruptor instead of getting disrupted. For instance, how to access Hugging Face, how to run free and open source large language models, generate text, images, speech, music on your local machine with your crappy GPU. And also how to use more powerful GPUs in the cloud, how to access it on the cloud, how to build complex multi-agent teams and systems with LangGraph, how to use OpenAI's API, building generative AI apps using Google's Vertex AI, LangChain, prompt engineering, AutoGen Studio, Voice First, OpenAI, Whisper. Basically how to integrate AI into your applications, how to access and plug yourself and your applications into the power of AI, so you can scale up your value proposition. So join us. Thanks for watching this video. I'm grateful to have you here. Thanks for taking the time, and see you in the next video. Bye.